Yeah. Okay. This. Hi everyone. Let's get started. Welcome to the SCITT working group meeting. It's obviously our first meeting. My name is Hannes Schufinnig and this is
John Gita.
We are your new chairs for this working group. Our first meeting, so happy to see you all here. Note well, you've seen that already, obviously because we are in the middle of the week. Roman.
Good morning, everyone. It's exciting to have our first kickoff meeting. I just wanted to publicly say, as you just did your introduction, Hannes and John, thank you for your willingness to serve to kind of get us started. So again, very much appreciated.
Thank you, Roman.
Yeah, thanks, Roman. As you have seen, we have a pretty full agenda. We will start with a problem statement document, kind of the problem statement, assuming that SCITT hasn't been done yet, so pre-SCITT type of thing. Then we talk about the use cases, same as well. Yogesh is going to talk about those. Then we switch into how does the solution look like with an architecture using SCITT. We have a presentation about the SCITT receipts, another document. If you click at the slides, you get to the documents themselves. There's a hackathon report which explains how you would use SCITT technology to actually solve some of those use cases. And then we have some time left for any questions that you may have. Is there any agenda bashing request? Haven't received any, so I don't see anyone jumping to the microphone. And if you go to the microphone, please use the QR code to add yourself to the queue. Okay. Yeah, we thanked Roman already. Thank you again for getting the working group scheduled so quickly. And one administrative thing. So we've had regular conference calls. We are going to continue those, and we will send out the doodle poll to confirm that the date that we had used, or which was a Monday and a Thursday call, that is actually good for everyone. But we will switch to using IETF tools and the whole IETF machinery so that we don't have to use sort of individual company sort of mechanisms here. Okay, enough said. Let's have the first speaker. You better do.
Hey, I'm Ori Steele. I'm here to present the problem statement. We thought we'd start with a quote this time about what supply chains are, and I'm going to read the quote for you all. A supply chain is a network of individuals and companies who are involved in creating a product and delivering it to the consumer. Links on the chain begin with the producers of the raw materials and end when the van delivers the finished product to the end user. Next slide. In the context of software, we're interested in software supply chain. So maybe the van part of the last piece is the only major difference. Software is an inherent part of everyday digitally enabled life. From smartphones to IoT data centers, widely discussed attacks on the software supply chain have helped raise awareness of risks. Many of the other vulnerabilities highlight the need for greater visibility into the supply chain integrity, transparency, and trust to make an informed decision. So just to be, concrete about this, one use case is a software supply chain focused on software bill of materials, also known as SBOMs, as evidence to a claim. That's it. So transparency and trust. Transparency does not prevent, you good? Transparency does not prevent dishonest or compromised issuers, but it holds them accountable. Any artifact.
No, I didn't do it.
Remix.
I clicked the wrong button and the internet is down. No, just kidding. I turned off the.
Further evidence of the delicacy of software. And we're back. So any artifact that may be used to target a particular user that checks for receipts must have been recorded in the tamper-proof registry and will be subject to scrutiny and auditing by other parties. What does this sentence mean? What are we trying to get at here? The important part is that when you ask about transparency, you want the answer to that question to be answered consistently. So if I ask about a particular artifact today, and my friend Mike Prorock in the back asks that same question in a few seconds, he should get a similar answer if nothing has changed. So it's important that that entity providing that transparency not be dishonest or be choosing how they answer those kinds of questions. And so we're interested in creating transparency and trust in that sense. And SCITT, an architecture for trustworthy and transparent digital supply chains, is a link available on this slide. Next slide. All right, and with that, I'll introduce my colleague Yogesh Deshpande to present software supply chain use cases.
Hello, good morning, everyone. I hope you all have a good morning and enjoying the session so far. And I want to keep you all engaged. Thank you, Ori, for great introduction of the problem statement. So I hope everyone is clear about the problem we faced, the challenge we faced in the industry today. So what I'm going to present here is going specifically a little bit more in detail in the software use case to explain you how this problem gets manifested in a much more clear way rather than little bit on the high level. I'm going to go in the little bit deep here. So next slide, please. So as you can see here, there is the software supply chain is a really complex system. You have multiple software producers like the operating systems, be it Microsoft, Ubuntu, and then you have the component vendors who are generating the chips or the firmwares on top of it. And then you have the package managers like PyPy or any software. And then finally, there is much other open source code or any proprietary code that goes to the integrator who then basically picks and chooses these components to produce integrated builds. And that too have multiple flavors, because different compilation switches, different features generate multiple products, multiple integrated solutions out of the same code base. And then eventually it goes to different companies, which then load those software onto the devices, and the device gets deployed into the field and gets to the hands of the users. Like we have laptops, mobile phones, all running complicated software, and this is the end user who is ultimately using that software. So this whole ecosystem is extremely complex, and how do you secure that this supply chain is a challenge in itself? So that's how, let's go to the next slide. So right now, today, we see integrator has a serious problem. Each time it is sourcing, it is not having a consistent and coherent information or the state of the each published components. And there is no standard way for integrator to query or receive. Even if we have software bill of materials, as we discussed just now, like SBOM to be getting delivered, we don't know how, is it the right guy who is shipping me the SBOM? Can I fully trust him? Can I fully identify his trustworthiness? Is the supplied component clean of any unexpected or any problems like vulnerabilities or anything, or how do I know that it has not been unexpectedly modified or suddenly changed because somebody hacked it and somebody modified it? So how does these kind of complex situations and problems the integrator facing today, how can he deal with it? So we start with a specific scenario we have built here to highlight the problem and explain you, and I hope we all understand the problem and the scale of the problem. So here on the left, we have an operating system producer, be it anything, as I mentioned earlier, Microsoft, Linux, or any operating system producer generates an executable and delivers it to the device integrator to integrate it into its system. And it has shipped this binary for device integrator and on a one-to-one channel. So next slide, please. Now the device integrator, as we saw in the first slide, he has taken other bits of components. The box, the pink box could not just be one component, but again, a series of components coming from other places. And he has generated an integrated device software, and it has been given to the device distributor for distributing it by loading it into on the device. Now the device distributor has the device ready, it has the software deployed, and the user is using that device. And suddenly user faces a problem. He finds something problematic with the software. He has some vulnerability, or he's running some scan or something, and suddenly something pops up. He's scared. Where exactly, in which software component is a problem? He doesn't understand anything because he's, at the end of the day, he's end user. He's just a user of a software. He's not, doesn't understand. So he go back to the distributor. Yeah, next slide, please. And here it is, everybody's, this slide just shows the flow, that the end user is complaining to the distributor. Now the distributor is not much knowledgeable about things. So he goes to the device integrator complaining that here is some problem. How do I fix it? Where is the solution? The device integrator probably tries to do some kind of a root cause analysis, and he's not sure though, but he hopes to identify and believes that it's the OS producers whose binary or the executable he has received has something problematic. That's why this chaos has been created. But that's just a belief, that just a kind of a kind of a assumption on here, happening here. So next slide, please. Now here we are in a stuck state, basically, because everybody is in a limbo, a situation where nobody understands what's going on here. The integrator is waiting for the OS producer to say something about it, to make a statement to say that yes, there is a problem or not. He wants to get an acknowledgement. The OS binary producer is still investigating, looking at it, and there is no coherent way of understanding and shared communication between them. Yeah, next slide. So the deadlock continues. Basically, what is happening here is that the operating system software producer is trying to show that it did all the steps correctly. So he's just saying that, look, I'm willing to share you the system details, how I have built this software, the build environment, the architecture. I'm willing to show you everything. But he's just stating that, or he's just showing maybe 6 months when the problem happened, and the time between when he produced the binary and the time when he's showing it is 6 months apart, and he's just showing it. There's no verifiable proof that what he's showing is exactly mapping to the binary which he has given, because there is no verifiability in the system. And who knows, the operating system software producer thinks that it's the device integrator who is blaming me unnecessarily, though it may be integration problem in one of his software. So we are just kind of doing a trust and a blame game. We are in a stuck situation where each one of them is just trying to play and leave the blame to others. And this stuck situation can have no clear resolution unless we have a standard means to conclude based on verification, where you can verify what is happening is a problem. You can identify the problem, and everybody in the ecosystem can clearly identify it in a transparent manner, and we can hold accountability on somebody's shoulders for where exactly the problem lied. Next slide, please. So going further, these are the problems we think the customers also faces when the end user uses the software, as well as the distributor who distributes the software receives that software, then it doesn't have any means to assess the risks or vulnerabilities in the binaries they distribute. The system integrator has no means to assess the vulnerabilities, as well as the OS binary producers doesn't have the same ecosystem in place there where they can see what software is produced, what vulnerabilities they exist, and when suddenly the software changes, what has changed, what vulnerabilities have been fixed, and there's no standard mechanisms to track this information. Next slide, please. So we identified this problem, and that's why we, along with our colleagues in the community, decided to form this excellent working group, which is short formed or acronymed as SCITT, Supply Chain Integrity, Transparency, and Trust. Basically, we are trying, our efforts are towards defining set of specifications which precisely deal with the problem which I have presented you just now, to introduce transparency in the ecosystem where an individual can look how the software was built. He can precisely download the stuff from in a transparent manner and verify. So next slide, please. So this is just the details about the working group, which defines compact integrity protected protocols supporting interoperability between multiple supply chains. It's focused on software supply chain use cases specifically, but it's very much in our focus to include software package repositories, container registries, services, and in the ecosystem, we would attempt to build a system which can deal with other use cases also. But right now, our focus is primarily on software supply chain. And we work closely with already existing IETF standard groups like COSI, RATS, TEEP, and SCITT as well. And we learn from them, and we interoperate, and hopefully we build a greater ecosystem along with them. So thank you, everyone. I think that is the problem. Now I would introduce my colleague, Anton, who would explain you the architecture of SCITT ecosystem. Thank you so much.
Thank you, Yogesh. So now I'm going to present the current status of the architecture draft that we have produced. So first, on behalf of all the authors of the architecture, I would like to thank everyone who commented on the mailing list or submitted pull requests on the GitHub for the architecture. Next slide, please. So I'm going to start with an overview of the core concepts of SCITT. And for the people who are there at IETF114, you may notice that we have slightly updated some of the terminology, but there is still quite a bit of controversy on some of the terms that we use to describe the concept of SCITT. So there is still possibly some changes coming, and don't hesitate to make your position known on the mailing list. So starting from the left side of the picture, we have the verifier. So the verifier is the person that is consuming the software artifact. And everything that we do in SCITT is for the benefit of the verifier. So everyday people that use software and they want to know what's bad things could happen if they use software, or help them decide whether some software is trustworthy. So the other important concept at the top is the concept of the artifact itself. So this could be, of course, a very wide variety of things. By design, we are very abstract in the architecture about what the artifact is. It could be a binary package, it could be a container image, it could be a script, it could be a Git tag, really anything. We only So the other important point is that we want to provide information to the verifier about the artifact. And one of the observations is that the information about the artifact can be coming from many different kind of sources, right? So it's not necessarily only the author of the artifact or the owner or the producer of the artifact that can provide useful or meaningful information to the verifier about its trustworthiness. And that's why we introduce on the right side the concept of issuer. So the issuer, it's any entity that can provide meaningful information about the artifacts that you use. So it could be not only just the author of the code, it can be the distributor of the code. It can be even automated systems like CI system, build system that provides build reports. This is very meaningful information that you can use to determine or audit the artifact that you are consuming. So in general, we call the information about the artifacts the statements. And the definition we have of a statement in the architecture is extremely broad. It's essentially any serializable information about the artifact. And what we require in SCITT is that we want to hold issuers accountable for the statements that they make. So we are going to require all issuers to sign the statement they make, and we are going to standardize the format that they use to sign this information. And this is what we call a claim. So that's the claim, it's the signed information from the issuer. And we're going to explain a bit later this claim issuance process in the next slide. The other critical concept, and that's kind of the central concept of SCITT, is the idea of the registry. And this is where the terminology is still a little bit controversial. So initially this was called the transparency service or the ledger service. Now we use the registration or the transparent registry or the notary. So if you prefer any of these terms, there is still a little bit of the decision being made about what is the right way. But the concept of the notary, it's an authority that is partially trusted. So the verifier is going to rely on the notary service or the transparency service to figure out information and to make sure that this information is globally consistent for all verifiers, which is going to give us some of the security guarantees that we provide with SCITT. And the role of the notary or the registry is that it's going to take claims from issuers and is going to verify their signature and is going to register them inside the registry, which is this tamper-proof or tamper-evident data structure that you can use to make sure that everyone has a consistent view of the claims that have been made by the issuers. And the second thing is that we require them to produce a standardized evidence, which is called a receipt. And the receipt is going to be able to prove to any verifier that a particular claim has been registered on this registry service or the transparency service. Next slide, please.
Dave, there was a question.
Yeah, Dave, the other terminology question or comment. Comparing this to like the RATS architecture, and I'm looking at, and so I was listening to your description of the registry and notary service, where it says that it verifies information from issuers, or the entity on the left is the verifier.
Mm-hmm.
And it doesn't use the word verify on the left side. So there's a little bit of terminology confusion that says the entity that verifies isn't the verifier.
Yes.
And you mentioned the little scroll piece there, you called that evidence, okay, which in the RATS terminology means something. In which case the verifier on the left really is a verifier in the same sense as RATS is, and the other one isn't really doing verify. And so I was just going to ask if you would elaborate on, Hank, if you actually agree that the one on the left is a verifier in the same sense as RATS and that this is evidence, and if so, then say more about what the registry does to verify, because the verifier is the one that actually does the appraisal.
Yes, so I think to summarize your point, what you're saying is that the verifier verifies the transparent claim or the receipt, not the claim itself. So it's a bit of an abuse. In some sense, that is a fair point. As I will explain later, the claim can also be verified by the verifier. It's a kind of advanced form of verification. But yes, I do understand that the claim terminology is a little bit problematic. And of course, as everything in the architecture, it's still an early draft, so it is possibly subject to change.
Yeah, so I guess that, I'll let, in case Hank has anything, but it would be useful to draw comparisons in text to the RATS architecture, right? One way to do it is to say the registry is like a RATS verifier, and the verifier is like a relying party. Okay?
Yes.
Another way to do it is to
Yes.
say that the registry is just a store and forward caching service, maybe it checks signatures, but it doesn't look at the claims or whatever, and the verifier here is the verifier, right? Both of those are potentially valid architectures, and I don't know if you mean one or the other or agnostic that both are okay, right? And so that's kind of my questions in the terminology. Thanks.
Yeah, okay. Basically, Dave said it all I think.
Yeah.
So yes, if the verifier looks into the claims, so into the actual statement that is signed by the issuer, then it becomes more like a verifier in RATS because it
That's
has
right.
to have reference values and policies about the content. If it is just an unjust,
Yes.
and that is the simplicity we provide here with transparency. If it's verifying the transparent claim, it becomes a signature checker in the end, because it is not necessarily required to look at any statements and to understand them. So that's first of all nice, but then also we understand the claim is used now for the third time in a different way. And so I understand, we understand that. And maybe a mapping like that will also maybe probably make us, give us a place to look at how to improve it in the end.
Mhm.
I just wanted to add with what Henk has mentioned. Yes, there is a little overlap with the terminologies between SCITT and RATS, but I think they can coexist with clear definition boundaries. What an interpretation means in SCITT may or may not have the same interpretation in the RATS world.
Yes, and I think hopefully the next slides will explain a little bit more.
But we still have one person in
Oh, sorry.
the queue. Dan, are you? Okay, good. If you go to the microphone, please use the tool, scan the QR code and put yourself in the queue. Remote participant then can also see your name. That's kind of benefit.
Thank you. Dan Drutz, AT&T. I like the architecture. I'm just questioning the need for this forked verification process. Is it absolutely necessary to have a notary service registry where in reality you can actually pass inbound with the artifact, the verification? And then the second part is basically also about the issuer, and maybe this is a bigger problem for supply chains. I'll use the Log4j example. You can have 5 issuers in one supply chain, flow that will issue Log4j, being part of their components. Who do you trust? How do you reconciliate in the end that it is exactly the same one? How do we address? Thank you.
Okay. So
Yogesh, you need to add yourself if you want to respond.
I will start with the first part of the question. So the first part of the question is what is kind of the role of the registry, and can we just pass the claim directly from the issuer to the verifier? So the reason that we introduce the notary is to give a stronger guarantee to the verifier. That's essentially the whole point of SCITT, and that's to make sure that any claim that is accepted by the verifier, the issuer can be made accountable for. And I will give some examples of the attacks that are prevented by using the notary in the future slides.
Yeah, this is Hank, just smallly adding. There's also, of course, the benefit of the point of singularity provides simplicity to scalability and things that might have no idea what a statement actually means. So putting trust into this fork enables like billions of devices to just forward it to the policy engine, for example, and to have nothing to know about it, which isn't possible if you can't put this trust into the middleman here. So it is for scalability and also for offline validation, and I think that's 2 critical features for the auditability in the end.
Hi, everybody. This is Elliot. So I think there's another possibility there, Dan, which is I submit a claim to the registry and I get back a response, and then I query the registry for the verification as the claimant, and then I just incorporate that in my packaging. And that way you don't have to go online if you don't want to, but you can if you want to. What's important is that, first of all, the trust anchors be in place so that the trust is possible. And second, as part of that, there should be enough information in the verification to say, here's how you can do this yourself in terms of contacting me from the registry notary. So make sure that in the response,
Yes.
there is an identifier, a URL or a URI or something like that.
Yeah, so I think yes, it's of course very advantageous feature, the fact that you can attach the receipt produced by the notary to your artifact or to the software, so that you don't need to do any online check. And that's, as also Hank said, a way to have to avoid for the verifier to understand all of the issuers of the artifact that they consume, and it's very difficult to decide whether they trust them. Using the semi-trusted third party of the notary, let them verify everything offline and let them apply very simple decision or policy at the verifier.
Hi, this is Brendan Moran. Just to provide a counterpoint to the deliver the claims with the artifact side of things, I noticed that firmware was one of your use cases. And if you're delivering artifacts to constrained nodes, you probably don't want to deliver all of the claims with them. That would actually be a terrible idea. So the point there is that that means that you need somewhere to store those claims, or you just lose them. And this gives you a standardized way to do that.
I'm looking at the line. I'm not.
Mike, where's Mike? Okay.
Sorry, I didn't see the act come up. Michael Prorok here. So yeah, I think another key aspect about kind of having an independent notary of some kind is the intersection of time, especially post-event, right? So if you had software deployed with some particular package that had a vulnerability unknown at the time, later on that vulnerability is fixed, possibly even inadvertently, right? You don't realize this. Being able to go back and backtrack after an incident to understand why, when, and exactly where that vulnerability existed, and having that record of time and when did this exactly happen, who witnessed it, were there multiple attestations about this particular item, right? Say a third-party verification, et cetera, all in one place. So I think that notion of intersection of time, especially in post-event, is absolutely critical when going through and analyzing an issue.
Yeah, Eric, not Mike. I was going to ask things around the same thing, right? Sort of a registry notary could just record, here's a set of, claims, and I'm going to store them, and they're not going to disappear. They're sort of handling non-repudiation, right? But you could also say, well, don't you want to keep track of what's the most recent version of that software? Yeah, but now you need to have a naming scheme so they can actually do that. And then the question comes out, do you also want to have reference to the CVEs that were in that old version, right? So what's the actual scope of this? Because it could actually balloon into something very big, right? As opposed to just being a trusted repository and no
yes.
Semantics.
It can balloon indeed. So the idea is that we expect that some notaries, so first of all, there isn't going to be any centralized notary for everyone. So every company or every organization can operate their own notaries. And some of them, as you said, are going to be very sophisticated. So for instance, they can indeed enforce advanced policies to make sure that a verifier only consume the most up-to-date version. And this is something that I think is in scope for some of the notaries. But of course, there are also going to be very, very simple notaries that simply record on the registry and provide this tamper evidence persistent storage of all of the claims. And that is, of course, much cheaper to operate. So in summary, we expect that there will be many levels of complexity on the instances of notary that are created in the wild.
Okay, Wei Pan from Huawei. I have two questions. First, I'd like to know to what degree the issuer will be. For example, Microsoft will deliver the OS operating system, and will Microsoft expose, for example, which employee developed which code to the notary service, or some kind of that. And second is about here the notary service will verify the information from issuers, and the verifier will also do some verification. I want to know the difference between these two verifications. Yeah.
Okay. So I'll first address the first question. So the first question is, I think actually I understand it as a privacy question, right? So for instance, if you have an SBOM that is, for instance, let's say your Git history, it's a very useful information, but some of it may be privacy sensitive, right? So yes, if you have, for instance, the Microsoft Windows SBOM, it will have the name of every Microsoft developer that contributed code, right? And in some cases, the question is, should this information be released to everyone or not, right? And in general, this is essentially a choice of the notary. So if you want to only partially reveal some of this information, you have essentially control over what are the claims in the registry that can be publicly accessed, or you can introduce some access control to the registry if you want to mitigate some of this concern. As for the second question, the question is the difference between the check applied at the notary versus the checks applied at the verifier. So this is explained in the next 3 slides, so please bear with me, I will explain it.
Okay, thank you very much.
We had, okay, the other person dropped out of the queue, but let's keep on going.
Yep, please, thank you. So yes, so as I said in the previous slide, there are 3 important flows or processes in SCITT. So the first one is claim issuance. The second one is validation of claims at the notary. And the third one is verification of receipts at the verifier. So I'm going to start with the first one. How do you actually issue a claim? So it has some, so as I said previously, a claim contains a statement. And SCITT doesn't really assume anything about the format of your statements. It just needs to be able to serialize it into some kind of byte string. And it could use all kind of standardized or defined formats for carrying SBOM, for instance. So there are many, many formats, and the goal of SCITT is to support all of them. The second piece, which is also interesting and a little bit controversial, is how are you going to represent the identity of the issuer, right? And this is where we have to make a technical choice for interoperability. And one of the things that is specific to SCITT is this idea that the evidence that is produced by issuer, we want it to be long-term, right? Which means that you want to be able to go back in time and verify all the evidence. And one of the important requirements that we identify is separation between the long-term identity of the issuer and the short-term credential that the issuer used to sign the statement. And that's why we currently decided to use distributed identity as the framework to represent the issuer identity. And our expectation is that because of the flexibility of DID in terms of defining new methods, this should be compatible with all kinds of identity systems, including, for instance, PKI based on X509 certificates, or identity system based on OpenID Connect or OAuth, or any kind of protocol. You should be able to define a DID methods to represent the identity of an issuer using DID, and you should be able to associate verification keys using the DID resolution mechanism, which transforms this stable identifier into a set of credentials, or essentially signing keys. So the last point is that there are some standard sets of information or headers that must be part of the SCITT envelope. And so when you want to produce a claim, you need to combine your serialized statements with this envelope information. And currently in the current architecture, we use the following mandatory fields. So the most important one is the issuer. So as I said, the issuer must be in the current architecture DID identifier that represents the long-term identity of the issuer. Then you have the information about the artifact. So for any claim, you want to know what artifacts does this claim refer to, right? And that information is encoded in the feed header. And you also have the content type, which tells you what format you use to represent your statements. So if it's, for instance, SPDX, SBOM, then you need to put that in the content type. You also have two additional things. So key ID is a mechanism to select the right key from the resolved DID documents. So you can have you can change your certificates, but keep your same DID. And the key ID will tell you which certificate to use to verify that particular signature. And registration info is used to, will be explained in a later slide. Next slide. So then moving on to the registration of the claim. So this is the process that is done at the notary when you want to register a claim on the registry service. So, so first of all, the person that actually submits the claim does not necessarily have to be the issuer himself. It could be some other party. And the reason for that is because sometimes you want to take a claim that has been produced by someone and you want to import it into your own SCITT instance, right? So in that sense, we separate the notion of being someone who registers the claim and being someone who writes the claim. And so the second thing is that we only require explicitly in the architecture that the claim must be authenticated, which means that the notary needs to resolve the DID of the issuer and verify the signature using the key indicated by the key ID in the claim. So that is the part that all notaries must perform, and that guarantees to the verifier that if they trust enough the notaries, then they won't have to do this DID resolution and signature verification themselves. And the second thing is that the notary may also apply all kinds of access control for or authorization procedures for deciding whether the claim can be registered or not. And that's essentially the trusted part of the decision, is that you have to decide, for instance, as a notary, who are the issuers that you trust, or who are the issuers that you consider valid. And as part of this process, you are even possibly allowed to inspect the contents of the statement itself, right? So you can have a notary that looks at automated logs and, for instance, will apply some vulnerability detection or try to detect if the SBOM that has been submitted contains vulnerable information, and if it does, it will reject the registration. And all of that, the notary has full freedom of applying any check that they want. The only thing that is required in the architecture is that the notary must return, if the claim is accepted, a SCITT receipt, which is, as I said, the proof that it's an offline verifiable proof that the statement has been registered in the registry. Next slide. Okay, so the last flow is the verification that happens at the verifier, right? And there is a little bit of subtlety there that is introduced because not all the verifiers are the same. So there are different levels of sophistication between the verifiers. So I'm going to start with the simplest type of verifier, and that's a verifier that mostly will trust the notary. And the idea is that we want to have the easiest time for this type of verifiers. It should be very easy, right? So you should be able to validate registration completely offline and using minimum information without having to even look at the statements inside the claim, right? And so for that, you are just going to use the receipt validation procedure that is defined in the receipt spec, and Mike will talk about that in the next session. But of course, you have some verifiers that don't fully trust the notary, right? And in that case, they can repeat, if they want to, some of the checks that were applied at the notary. But so this type of advanced verifier, we call them auditors. And the purpose of the auditors is to effectively keep the notary honest, right? So if nobody cares about what the notary is doing, then you don't really get a very strong property for the everyday verifier. But if you have some auditors that actually verify that the notary is checking the issuer signature properly and it's applying its registration policy properly, then that essentially keeps the notary honest. So there is also, yes, I think we covered in the question most of the points. But there is one question. Yes. I think there is someone in the queue.
Oh. So just a quick clarifying question. Is the notary or is the auditor replaying the whole ledger or just relevant to some particular application? What exactly is the auditor auditing?
Yes. So it's up to the auditor to decide. So it's possible to audit the full ledger. Of course, that can take a lot of time. But you can also partially audit in the sense that you can, for instance, select an issuer and only replace the registration of the claim for that particular issuer, or any kind of subset, right? So I think part of the point that is maybe not answering your question is how do you, as an auditor, how do you query the ledger? And currently, we have decided we are not really specifying what is a standard API for auditing or accessing the registry. And that is definitely one of the open items for the working group to work on, whether we, so what kind of queries or what kind of APIs can be used to actually audit the ledger, that is still an open question.
So, and it's an after the fact audit, or does this happen in real time?
No, it's after the fact.
Okay,
everything is after the fact.
Okay. Or Steele, just to restate the answer that was given, there's sort of three ways to think about the audit process. The simplest case is you're auditing a specific transparent claim like one. The more advanced case is all transparent claims made by associated with a particular issuer. And the third is the entire transparency registry, which would be very expensive. That's it.
Okay, so now going back to what we discussed earlier about what is the guarantee that we give to the verifier, right? Because ultimately, there is all of this machinery for the issuers to operate the register, the notaries. So all of that, it only makes sense if there is some benefits for the verifiers. And so the main benefits of SCITT is to guarantee the accountability of issuers. So we want to be able to prevent equivocating issuers, which would be a class of issuer that give different claims about the same artifact to different people. And that's a kind of way to distribute bad code. There is also this idea of accountability of the notaries themselves. So we don't want to blindly trust the notaries. And that's why the registry is there to keep all of the evidence to allow an audit after the fact of what registration policy and what checks were performed at the registry. Right? And this gives both the auditability of the claims and auditability of the registration policies that were applied by the notaries. Question.
Yeah, thank you. Dan Drutze, AT&T. Now that everybody convinced me that registries are good, I just still have a challenge with the architecture, because as far as I understand, you look at the architecture, you got the issuers and verifiers, and that gets replicated. So a verifier can be an issuer, it may be using a different registry, and at that point, I'm questioning how will the registries inter-registry trust?
Yes.
And then how do you really reconcile with this? Because as soon as you said that everybody can have their own registry, I thought, oh my God, now I hate centralization, but I hate mass distribution. Thank you.
Yes, obviously that's an important question. And it's not an easy one. And we had a lot of discussion about this during the hackathon, and this will be addressed in some of Hank's slides in the hackathon report.
Yeah, I basically just came up to say that there's a hackathon report where we talked at length during the hackathon specifically about these interledger scenarios, and there's some good visuals, and Hank and I will be speaking to that.
Dave there, I was just going to ask if you can elaborate and just say more about how you detect incorrect claims.
Yes.
If you can
Next
just say more. Yeah.
So I do have some concrete example to show you.
Okay, cool.
So this is a concrete example of an equivocating issuer, right? So it's an issuer that is going to produce two versions of the software, and one is going to be using honest code, and one is going to have malware or virus or whatever. So in that case, the issuer is a malicious one, and he wants to attack some of the users. And the idea is that if you force so if every verifier is going to require a receipt from the notary, then the only way that this would actually be possible is if the issuer registers both of these claims on the notary. And then two things could happen. So either you have a quite advanced notary that is going to actually look at the contents of the claim and possibly detect that the second claim is a bad one. In that case, the second claim may even not get registered at all. But that's kind of optimistic. So pessimistically, let's assume that the notary is relatively basic and both claims actually get registered. So in that case, you still have the registry itself as essentially long-term proof that can be used to detect by auditor that the issuer was equivocating, and it can keep the issuer accountable because you have enough proof to blame the issuer. So the non-repudiation arguments through the ledger tells you that it was the issuer that was malicious. Next slide.
Did that answer the question, Dave?
I think so. Let me tell you what I got as the answer. That your definition of correct relies on the same answer being given to everybody.
Yes.
If you give the same wrong answer to everybody, it is not incorrect.
That's right.
Okay. And so that's the definition of incorrect, is that it has to be the same for everybody. So
Exactly.
It doesn't mean that, say, Microsoft couldn't publish something and say, this actually comes from FUBAR or whatever. So you can do spoofing and stuff, and I understand you're actually solving that by the signature checking and the trust in the issuer,
Yes.
rather than checking the values of the claims. And so if it comes from an issuer you trust, you just assume that they're actually not lying about any of those things, right? So correct just means it comes from an issuer that you trust, and they're giving the same answer to everybody, and that's the answer to my question.
Exactly. That's exactly right.
I think that would be important to capture sort of in the architecture document if it's not there already.
Yeah, the other, just because this is about the fourth time, I think the same form of question has come up. So if you refer back to Ori's second statement on what transparency offers, the first thing is, yes, we can see it. But the really important second thing is you have to have registered your claims at a verifiable point in the past in order for them to be valid, which means you have to have all of your operations laid open, which means you can't selectively lie, cheat, repudiate, or whatever. And it's a responsibility on the verifier to not accept statements that are given post facto, out of band, or whatever, because otherwise all of these other things fall apart. So it is a whole system responsibility.
Diego.
Okay, a couple of things regarding the roles of the notary, the issuer. You mentioned one thing that, somehow concerned me when you said that the notary is a very simplistic one and cannot verify that the malware is there or not. My understanding of the notary is that is a totally, is the operator of the transparent registry. It's not going to make another additional checks, because in that case, the notary would become an issuer. With that, I'm not against that you have notaries with issuers inside that make additional issues. But my understanding is that the notary is just, it puts an envelope, a sealed envelope around wrapping the claim, right? Or are we thinking about other roles for the notary? Because that would complicate the whole thing.
So the notary role can be a little bit more complicated. I have also a slide on what it means for the notary to perform additional checks. But the semantics is that accepting registration of a claim is it's a form of endorsement,
yeah.
right?
No, basically, yes.
At minimum, we require that it means that the notary must have checked the issuer signature. That's a baseline. But you can also perform additional checks for which the endorsements in the receipt would be essentially a witness that these checks have been performed by the notary.
But wouldn't that be an issuer role rather than
No,
a
it's
notary?
not an issuer role. Again, the difference is that it's an endorsement. You accept a claim that was made by someone having checked some additional property, but it doesn't mean that you are authoritative for that particular information. The claim remains the responsibility of the issuer.
And that brings me to the second is about, I mean, composure issues, because in all the examples, the issuer is apparently the developer or the vendor of the software. But as a user, I could want to make another issue, to issue another thing that say, I tested it and it was right.
Yes.
And that's fine, right?
And that's fine. You are encouraged to do that. So as I said, you can collect a large number of claims for the same artifact,
So
including
we're talking
audit
about
reports, including
sort of meta issues or compound use. Okay, fine.
Yes. Okay, so I'm going to skip over the next slide because I think I'm a bit running longer than I should be. So
yeah, running a little bit out of time, but maybe we could shorten the policy. You want to shorten the policy or this one?
So I was hoping to just okay, maybe we can go to the last one, which is how do we solve the use case, right?
The customer.
Yeah. So yes, I think this one we don't really want to solve because this is supposed to connect everything I've explained to what Yogesh has explained before. So it's basically a summary, right? So we want to be able to assess the risk of software vulnerabilities from the artifact that we consume. And we achieve that by requiring at the verifier to have these endorsements from notaries or the verification of the receipt to make sure that everything can be audited later and that the issuer and notaries are kept auditable. So the architecture supports uniform methods for issuing statements. So that's the first flow that we reviewed. The verification of the integrity, authenticity, and timeliness or freshness of statement. That's the role that is mostly assigned to the notary. And creating consistent, abundantly verifiable records of statements, that's the role of the SCITT receipts, and that's what drives the verifier flow. So user-defined are the policy for determining which statements are trusted. So unfortunately, I had to skip over my policy slides because there are three types of policies. There are the policy at the issuer, what statement do you endorse, do you sign? There is a policy at the notary, what claims do you accept, which is a form of endorsement. And then there is a policy at the verifier, is can I trust this notary, or what additional checks should I perform, right? So I hope that was a useful overview of the architecture. Everyone is welcome. It's available on the data tracker to submit comments on the mailing list and suggest improvements. Thank you.
Excellent. Are there some further questions on this topic? So it's obviously a lot. The document contains terminology, talks about all the things we spoke about just now and more because we skipped a few things. And so it was our impression that we should do a call for adoption on this architecture document as a kind of a starting point so that we have something to work with. And I'm going to, of course, we have to confirm that on the mailing list, but I wanted to do a show of hands using our famous show of hands tool. If I figure out how to formulate the question. Do you agree? Yeah. Yeah. Or do you support? Okay. Okay. So in essence, I'm asking in a complicated way of whether you agree, or if you don't raise your hand, disagree with adopting the architecture document as a starting point. That I'm saying as a starting point because, like, as Antoine mentioned at the beginning of the talk, there's the terminology, still the rough edges, and of course there was feedback during the meeting which we need to capture, and I'm sure there are a lot of other things missing. Okay, I'll run it for a few more seconds. Okay, so here's what I have. I end the session. Oops, it was 36 to 3. So 30 for the meeting minute taker. 36 people were in favor and 3 were against them. That's a pretty good response. We'll do a confirmation on the mailing list next week, and yeah, see how that goes. And okay, that's what I wanted to say.
Okay, thanks.
Thank
so
you.
I'm going to hand over to Mike for the receipt.
Hello, everyone. Mike from Microsoft. Mike Richard. Okay, next slide.
Okay. Need to get close to the microphone, just eat it. Yep.
Is that close enough? Okay. All right. So we talked already a bit about receipts in Antoine's presentation. So I'm going to summarize it just a bit. So what is a SCITT receipt? It's basically a proof that a SCITT claim has been successfully registered in a transparency service. And okay, ignore terminology, we know registry, notary, all of that stuff. I'm going to call it transparency service in this presentation. Registration means that you have your registration policies applied. And what that means, what Antoine said already, you need to verify the claim signature. And there can be other policies, obviously. Then as part of registration, you store the claim in the registry, so the ledger. You produce eventually a receipt and return that to the submitter. And obviously, if we define APIs, etc., then there's always also a way to retrieve the receipt, not just by the submitter, but also at a later point in time. I think we'll probably do that. And yeah, the important bit is that the receipt, it's an offline verification of the claim. So we should probably qualify that, what that really means. But it means all the points that happened before have happened. And you can, by verifying the receipt, you can make sure, if you trust the notary, that those things happened. So yeah, it's quite simple. It should be simple. I think that's the idea. Next slide. Okay, so now we get into a bit more of what a receipt actually is. And if you think of a transparency service, you can think of it a bit like an electronic notary. So it does certification on the authenticity, sorry, I'm German, it's hard for me, of the claim signature. So that's one thing. And then it also certifies any additional registration policies are applying to the claim. And so if we look at it like that, then treating it like a counter signature on a technical level, also, peeking a bit into, cozy counter signatures or any other counter signatures like in CMS, etc. Then it means you have this nice property that you can embed receipts in the unprotected part of your claim. And so you have this nice bundle and you don't need to create another wrapper structure that makes it even more complicated. And so we basically take inspiration from cozy counter signatures, but it's not exactly that. And I think, yeah, I'll talk more about that on the next slide. So next slide, please. So why do we need a new format then? Can't we just use standard cozy counter signatures for that, since it sounds the same? Well, not quite, because a cozy counter signature would countersign a single individual claim, but in transparency services, usually what happens is you put claims on the ledger, and then eventually you sign the Merkle tree root of that ledger. And so there's a bit of an indirection there, and that's handled with inclusion proofs. And this extra step means we need something, that allows verifiers to do this step. And we had some discussions that we've now abandoned on whether we can, kind of shoehorn those details in existing cozy concepts. So actually do use normal cozy counter signatures. And we had the idea of, okay, maybe we can actually, just create like a new, SCITT receipt signature algorithm, and then stuff everything into the signature bytes and make it a bit more of a meta thing. But the community widely disagreed that's a good idea. So I think we'll just abandon that, because it would just lead to too many, roadblocks on the way. And people generally agreed that exposing the concept of transparency, the fact that you have ledgers, that you have inclusion proofs, a bit more to the top of the format seems to make sense. And if anyone wants to look up the discussion we had on the mailing list, there's a link at the bottom. Next slide. All right, so don't look at that too closely. It's just a very rough first draft, and I'm really glad that we have so many people in here that deeply care about formats, and that are also involved in cozy and structures and all of that. So the idea is we have this new thing, we call it receipt, and we have very likely, at the moment we do have a protected header. We can also add an unprotected one if that makes it easier to, slot into existing structures. And then we have all the other stuff, which is the inclusion proof, the actual signature, and yeah, and we have to figure out exactly how that works. One of the challenges is that we have to think about multiple types of, ledgers, because they may have different Merkle trees even, and slightly different ways of hashing, the leaves and the intermediate nodes, etc. So there has to be a bit of flexibility on, we call this at the moment the tree algorithm, but we have to see which parts we can make common in this format, and which parts are just kind of like an algorithm that you have to define somewhere, and then you have to define the pieces that would go into something like a signature bytes. But in this case, it's not a signature bytes, it's more like the, how do we call this? Ledger bytes. But yeah, let's, and I think that's where we'll have a lot of actually discussions, and I hope we can converge on something that makes sense. The protected header, what we have in mind for that is that it's not too much different from the protected header, what you would put in there in normal cozy signed messages. So it needs to be some kind of identifier of the transparency service, so that you can do key lookups and have a strong identity over that. And there are, even on that level, there are variations on what that could be. It could even be a DID at this point, but there are some services that may use mainly certificates. So we have to see how that all fits together. Certainly, it would be a little bit nicer if we actually, since we already intend to use DIDs for claims, it may make sense to also do that for the transparency services themselves. So, and then, yeah, as I said, we have 3 algorithms. Microsoft has recently open sourced a kind of prototype implementation of this. So, and for that we use CCF. And again, the format for that is draft. but we can imagine that there are more than that, trillion, for example, QLDB. And apart from that, there may even be different variations of receipts. So we have some thoughts on the kind of the primary receipt when you store something in the ledger, but then also something like when you read something from the ledger and you want to get extra guarantees that this is still fresh. So there may be different types that also we have to encode somewhere in there. Yeah, and then an issue time of registration. It's very useful. Yeah, and then the proof, as I said, that's in the draft, by the way, we call it contents at the moment, but maybe that's not a great word. Proof is also probably not a great word. So there has also been some suggestions to actually split this up into, kind of ledger bits and then have signature as a separate field. Maybe that works. We'll see. Next slide. Yeah, and we had an extremely short slot in the COSI working group session on Tuesday. So just a few minutes to advertise that, I guess, and get the idea out. There was no immediate objection, but I wouldn't necessarily count that as approval or anything because the time was so short. So if anyone has any feedback or wants to collaborate on that, find us on the mailing list. And we will also do the same. We'll engage with the COSI folks and work together on defining, bringing transparency to COSI. That would be the goal. I think that's the last slide, but yeah, okay.
Any immediate feedback on the receipts? Carsten
Like
likes
a thumbs
it,
up.
gives it a thumbs
Okay,
up. Yeah,
that's good.
Yeah. Excellent.
Okay, so I don't actually know who's next. Okay, so that's Hank with the hackathon report. Great, and Ori as well.
Ori, do you want to
on
the previous topic? Okay.
Yeah, so Oristio, just to ask about the draft status for receipts, the document associated with this. Are we at a similar stage for a call for adoption for the working group, or do we still want to wait for the call for adoption for receipts?
Yeah. I would let it settle still a little bit until we, there's some, as next steps so in general, we have the use case document, which I expect to be rewritten and improved. And then there's the architecture document, which has obviously lots of open issues, like getting some of the terminology sorted out so that we don't use different terms all over the place. Would be good. And then we will do a call for adoption of the architecture document next week. And so I hope this advances. In the meanwhile, there was more feedback from the COSI group and also from this group. I think the attention is still at the architecture level, use case description right now because of our first meeting, obviously. But yeah, Roman.
Hi, Roman Danili. I was jumping the queue to really endorse that position for the working group. Let's get what we want to do settled, and then we can talk about how we want to solve it, because I don't want to get us in a position where we're talking all about solution things while we're iterating what exactly we want to solve. And I think that's just going to give us a lot of focus.
Given what Roman said, I'll just withdraw from the queue.
Enough said.
Wise words.
So hi, this is Hank. I will give a first part about what we call a hackathon report. We did not produce any code at the hackathon, so we wasted a lot of paper. I'm apologizing to the impact on trees. Next slide, please. So what we were talking about is the thing that again, is a terminology snafu. So the initial information that is about the artifact is the statement. And then the statements can be big. So we are talking about how to detach the actual, when you register that, the actual statement from the place where you register the statement, so that you can have a tree, because most of these registries / notaries are trees, hash trees, Merkle trees. We would like to separate terabytes sized statements from that. We found 9052 that says, not our problem, do this on the application level. We found 9054 that has at least the how to find things via that. I think based on through these two fragments and maybe a location where to find it. I'm doing some cross advertisement here. This can of course be a URI that is resolvable, or a CRI that is resolvable, or a URL, or a CRL, sorry. That isn't actually a thing, I know. So, you know, URLs are for humans, URIs for humans, CRIs are for machines, and this will be big at some point, so you want to make it small and concise. The proposal is to actually, I'm not sure if this has been done before, so if it has been done before, we were happy about pointers, but to create a detached cozy envelope, especially for the sign statements in SCITT. Next slide, please. And maybe Brendan wants to say something before. But next slide, please, again.
You should know this. It's a
oh,
SCITT
yeah,
reference.
it's a SCITT thing. But SCITT is different. It's the same, yes. And maybe we will do it the exact same way, but we have to go through all the steps again to find out if we're doing it the exact same state. So I'm not entirely convinced. But maybe that's the result. So discussions. Why? There are things out there. So we want to not only just build totally new systems with our building blocks, we want to help existing systems. We want to be integratable into systems easily. So, and one of those are content addressable storages. They're already out there, like a ton of them. And that would be in support of those. And I already highlighted as a spoiler that statements can be big and there might be drawbacks and having the statement included in a tree. Then there are also regulation problems. First of all, it might just want to expose it. You want to expose the fact that you are accountable for what you say. You want to expose the fact that you said it, or what exactly was said. You want to have more fine-grained control about, more than a notary might allow for. So these are then hosted somewhere else, and you have more fine-grained control about the accessibility. And then again, there might be a personal identifier information in there. So of course we have to address that. Some disclosable claims, there's work in W3C about this. Might be a solution here, but again, that is a separation of duty, and that is again another reason why we would like to do this. And now Michael has a hands up.
Yes, Hank, I'm going to iterate the need for statements being big with some of the data sets we're dealing with and software assets we're dealing with that feed into this. I did also want to ask, with your experience with the hackathon side, did it expose anything around like terminology and use cases that would echo support for what Roman stated earlier as far as Letscape core architecture? Because I'm noticing a lot of conflicts between terminology slide to slide.
Yeah, we too. And so imagine having time from Saturday to today and not being able to resolve these. We apparently need a working group to help. So that is my first initial response. Also, I think we have developed a few good proposals that we will admit to the list. So there's another thing. So the hackathon also has something about that, but we can't show everything the hackathon because of time. Let's go to the next output. This is basically output 1. Output 2 is also about statements. And this is my title. We are not the curators of 1,000 semantics. Somebody was talking about policies that check the content of statements at the notary or registry level. Yeah. this is not a centralized thing that can be standardized. You can maybe standardize a module interface for some specific statements that you plug in, but are self-responsible for that. Maybe even issue your own claim on the registry that you're responsible for that. That would be funny, but also possible. It is actually a nice system. But the important point here is that maybe some of these statements are not opaque to the notary by standard. Maybe we want to create some standard statements, and we can go to example A, which is this deferral hash link, and there's the actual statement. That is a standard statement that we could define. And there might be more than just this one. So the proposal is here to define a small set of named and registered standard statement structures that are actually transparent to the notary and everybody using solutions in the registered notary system. So next slide, please. There are two examples that we found interesting to discuss. There might be universal ones like a revocation, but we don't revoke anything because we are audited after the fact. We refresh our opinion. Of course we were wrong. And maybe it's still okay to say the one thing, like build buildings with this. I'm doing a non-software analogy, right? Build buildings with this, and 20 years later it's like, yeah, okay, buildings are still fine building with this, but it's not fine for humans. So maybe not build buildings for humans with this. And so this is an additional information you want to augment. And so that's something that is a semantic relationship that can be transparent. So refreshing a statement could be a standard statement structure that is also not opaque to the system. Then we talked about endorsements a lot. A issuer talking about another statement that's already in there. And that might be something that you really want to elaborate on. That could be, for example, yet another transparent statement. So why? This is in support of the solution. So we can't just build building blocks because they look nice. We want to enable people to integrate them into the systems or build new systems with them. And typically you have something to query for the information. There will be APIs, there will be indexing servers, there will be huge scalable systems that help you understand that I want to and can use this software. So in order to do that, you need some interlinked things. And now going to the third output, there might be interlinked things that you don't understand. Let's open, next slide, please. Exactly. There might be references to other transparent statements that are opaque to the notary and maybe even to the consumer at some point. Auditors might understand them, or a very, very informed end user might understand them. And still, you want to understand easily to build graphs that they are linked. So there's a semantic relationship that is super simple, that is kind of obvious when you don't want to talk about content of statement. That is this statement refers to the other statement. Like a refresh would, of course, refer to its complement. And now we're asking ourselves, how would we do this actually? If you can't really infer by the statement content, because we are not the curators of 1,000 statements, how do you do basic relationships? And is one edge like, connected? Is that enough? Is that enough as an agnostic way to do this? And next slide, please. And then Michael can say something.
I do. I just wanted to emphasize an interesting thing that's kind of topical. In the US, we have a food safety regulation that just hit the wire. It's been debated for a while, but is now going out, where the FDA has specified the content, the payloads, and all these things that have to be collected, but has no mechanism, right, or way to go ahead and actually provide auditability on when certain events happened from a traceability standpoint. So it's this intersection between the digital side and the physical side. And so one of the things I like about this is that it provides that ability to say, oh yeah, these guys over here said what content has to be tracked and what types of events have to be tracked and how you need to be able to get that data back to me. And this provides a mechanism to verify that data. So it's highly important from that food safety aspect for sure. So.
Yeah, and a lot of other in the supply chain world, in the software supply chain world. Okay, now it's short. Okay, whatever. So why? So again, as I said, integration into existing system is really, really important to us. We want to have feedback of people who can see a benefit of adding SCITT components to their solution and understand how integration really works in the end. And I think one example here is that you need your own software, and you actually have a few transparency services like registries that, again, terminology, that you trust. So you need a remediation guidance because you know about a vulnerability disclosure report about your software, and you can actually identify that software via SWIT in your system. So that's a complicated query. All these things have to be kind of followed in a semantic transitional way. There's some there's no direct relationship between them. And still you want to have a remediation guidance, because what you want to do is the most important thing for incident remediation. So that is a good, I think, example why these relationships are necessary to some extent, and why we can't still make them specific to the statement content, because that again might be PII, confidential, or totally obscure, or an OCR, not OCR PDF endorsement. I've seen these things. Everybody's seen these things, right? So it might not be as possible as we like. And so so these are digests from the hackathon. There were more, but literally digesting 3 relevant topics out of 2 days of hard discussions all over the place. I think that's a pretty good summary of 3 of those. I will hand off the multiple ledger scenario to Ori, if there aren't any questions here right now. And that's not the case.
All right. Oh, sorry, I'm gonna have to move this down a little bit. There we go. Yeah. Right. So there's a number of ways, like as Hank just mentioned, there's a number of ways where there might be some first thing pointing to a second thing. And based on the architecture you've all seen today, you can probably imagine there's more than one way to do this. So we thought about this. We talked a lot about this at the hackathon, and we have some strong statements to make about how we think it should be composed. And if you agree, great. If you don't agree, also great. And please share your opinions about this on the list and engage in the documents and issues. But I'd like to explain this picture just a bit, because you can see here there's this first statement, there's validation, the issuer performs the issuance operation, they get the signed statement, we called that a claim earlier, we're not talking about the terminology problem anymore. And then there's a registration to create a transparent statement. And this is the first place where you have these 2 things, the signed statement and the transparent statement. And you could link from either of them to the beginning of another process. So which should you link from? Not the signed statement. And that's our opinion based on many discussions. So I'm just bubbling all of that up. If you have a good reason why you think that this is good, or you know, the other one that was bad, please come talk to us. We're happy to have those conversations. But this is the yes, this one is the one we think should happen. And you know, there's good reasons, lots of good reasons for that. But the main thing I'd like to point out here is that in the next slides, you're going to see several sort of arguments about transparency services. And so this one is more useful in those contexts than the previous one. Next slide. So we talked about a software supply chain use case before, and I wanted to show another, you know, brief summary of an example in a different sort of domain. And I wanted to explain what it might look like with a single transparency service to solve this problem. And then I'm going to show you some other pictures that have some additional benefits in terms of confidentiality. So in this story here, we're going to have a device driver author who's going to make a first claim about some GPU hardware, firmware versions, measurements, FIPS certification. To have that first claim is going into the transparency service, and we're getting receipt out. Then later an OS vendor is preparing their OS bundle, vendor name, FIPS compliant build versions, and they're including this first receipt here. And this little square failure to process UTF encoding deal is signifying that there could be a problem here in the inclusion of information about this device driver's output. And so what I'm trying with those little black question marks is trying to indicate that there can be, at any point, there could be inclusion of information that you might want to get back to, and that's why you want those going into the transparency service. So at the end of the second process, a second receipt is generated, and in this final one, you've got claim 3, and claim 3 is from a cloud service provider, and they're going to be creating some claims about the information they have about receipt 1, some information they have about receipt 2, the workload measurements and SLA promises, and they're going to generate a final receipt. And in this, this is what the auditor would see if they view this transparency service as each of these claims and receipts. And in this case, we might imagine this cloud service provider is offering a new magical streaming, video streaming service on top of an operating system and some GPU device driver information to process video at scale. And so they want to get committed transparently to all of the components that go into delivering that service in case in the future something bad is happening with the video streaming processing and they need to do an analysis. So that's the story, and the same story is going to hold in the next slides, but we're going to show a slightly different version of the architecture we discussed. Next. So same architecture, but different deployment models, I should say. So in this one here, we've got the same story, but we have now 3 transparency services. And in this case here, I'm no longer having Unicode parsing issues because I'm just here to talk to you about the flow in the happy case, not in the case where there's an error injected in the system. In this case, we have receipt 1 and receipt 2 going into claim 3. So this one, the OS vendor doesn't see that intermediate piece. Because receipt 1 is going over the OS vendor and into the cloud service provider directly instead of through the OS vendor. So this is one of those cases where it's like, did I bundle that dependency, or did I ship a binary that would require the integrator to bundle that dependency? This is a difference between this one and that one before, and also the transparency services at the bottom. Now, we're not commingling claims and receipts from 3 parties into one transparency service. We've actually given each of them their own transparency service to store these. Next slide. Questions?
In general, I agree with these 2 models. The FIP certified is a bit confusing.
Sorry, just a
example.
Hypothetical example kind of claim being made, and I was just fishing for good words other than claim 1 and claim 2.
Yes, because there the OS would need to certify with it.
Yeah, that exactly. Awesome. Next slide. So the main point I want to make here is that in the case where the transparency service is segregating claims, previously we were looking at the auditor's view across 3 separate transparency services, and maybe each of those entities operating that transparency service is going to comply with that auditor, and that auditor will have deep visibility into the claims on that transparency service. But it is also possible to have just the view from the device driver author's perspective, so for my transparency service for my device driver artifacts, I can see everything that I've put in there, and I can see all the receipts that I've got and that I can hand out to all of my friends who desperately want receipts from me, but I can't see any of these other things. So just go back for 1 second to show behind the cloud one more time. There's a lot of complexity that happens afterwards. But I'm, as the original, if you think about it in the original definition from the beginning of the slides, the raw supply chain materials producer, they don't get to see how their outputs are consumed at every intermediary from that point on in time. One slide. Again, to them, they make their first raw material output deliverable, and then it goes into the supply chain. It moves along. They still have visibility into the transparency service that they're anchoring their claims and they're generating receipts from, but other parties are consuming that information and seeing those receipts nested into subsequent layers within the supply chain. So we talked about these different deployment models for the same architecture and the benefits, especially in terms of confidentiality and segregating by use case for the different vendors, et cetera. And this was another output from the hackathon, not code, but pictures. That's it, I think.
Mike Perak here. Ori, did the topic of, say in this case, right, device driver author getting receipt one of the thing they checked in, did the topic of the author knowing who was requesting their receipts out of the transparency service come up at all?
Yes. So go back one slide. So here it's very clear. Cloud service provider needs receipt one. And you can imagine that maybe cloud service provider is just one of many cloud service providers that needs receipt one. The important part is that the receipt one is there and can be given out to anyone who may need it. Did I answer your question?
No. Does the author?
Oh, the author, as in like
who the cloud service provider, right? So device driver guy, does he know that cloud whoever is using his stuff?
I suspect Antoine may be queued to answer this question, but I think the short answer is the access control policy for the transparency service is the gating factor that answers that question and not the original issuer of the claim. So the answer is no, the original issuer of the claim is not informed every time a receipt is handed out to a relying party or requesting party.
Yes, so my comment is on this idea that you always have to, when you are consuming or depending on receipts that are in other transparency, it always goes downstream. And one of the things that was discussed in the hackathon is not just only how to refer to these dependencies by value with a detached thing, but also there is a question of how do you actually refer to this dependency by reference in a way that you can have essentially a global addressing scheme for accessing claims that can be registered at any transparency service. So maybe you can give us some idea of what's the best way to create this kind of global access to claims.
I'm not sure I fully got the question there. Is it how to discover which transparency service will offer me which kinds of receipts for claims?
No, it's more like if you want to refer to a claim, but just refer it through some URI or streaming direction.
Yeah. So in the case where a claim is a content addressable identifier to a large artifact sitting in an artifact repository, how do I find all receipts for that content addressable identifier across multiple transparency services? A querying question. And there's a section in the architecture where we talk about potential querying interfaces that could help. And in Antoine's slides, when you're looking at the header, you're seeing the content type, the feed, and the issuer. These are all hints about how to get back to the claims you're interested in.
Yeah, I just wanted to kind of highlight to Mike that this model is very much specific to a deployment where the device driver author is maintaining its transparency service, and it's kind of the rest of the how its receipt is utilized is really not for him to kind of make understanding of. But this one is the right one to say that the receipt is gone. Who is using it is up to them to basically put it into down the line.
Yeah. So this is not a system for creating, some form of global surveillance over the consumption of all claims and receipts. This is once these things are secured by the transparency service, where they go is at the discretion of the people who hold them.
Absolutely. Yeah. I hope that clarifies a bit of, yeah. Thank you.
Yeah, Carsten Bormann. These are all services where we really want to have a choice. I think that's really important. Of course, the question really is who has a choice? And if one author publishes through a specific transparency service, I don't really have a lot of choice if I want to use that author's output, which transparency service I use. And I think beyond integrity, which is right now our main consideration, I think we also have to look at confidentiality at some point.
Confidentiality?
Yes, and in particular, the privacy aspects. I think that they are pretty much orthogonal in many ways. But I think in the end, it is important for the whole system to function, to have certain quality criteria with respect to privacy that these services may or may not fulfill.
Yeah.
So it's, for instance, possible for an integrator to say, I'm only going to work with transparency services that provide certain privacy guarantees as well.
Excellent. Yes. So in this picture, I made each of the sort of tiers a different color, but you could imagine that maybe device driver and OS vendor use the same kind of transparency service, but the third one uses a different kind. So that's speaking to your question about choice in transparency service. You know, if there's only one, then there's not a lot of choice there. I personally would like to see a lot of choice in interoperable transparency services. And then the second point is about the confidentiality, and that applies to the registration policy from the architecture slides before. So if my registration policy is, I'm going to be very careful about registering anything that isn't that's by value. I want to only include registrations by references. That's my preference because I'm very concerned about accidentally including large amounts of information that might include PII. The registration policy can communicate that to potential transparency service consumers so that they can evaluate that policy and decide, is this the kind of transparency service that I want to submit data to? Do they reflect the privacy values that I have?
Yeah, there are several actors here that have different privacy requirements, and you really have to look at all of them. And maybe one of the jobs of a transparency service is actually to improve the quality of another transparency service by offering services that have additional privacy criteria.
Yeah, just one other thought on that is, I think it's mentioned somewhere in the slides, but the idea that part of my registration policy evaluation might have to do with claims I've already seen, that have already been anchored. So I think that's another dimension of what you're saying.
Yeah, thanks for the answer. I just want to reaffirm that it's a critical part of the architecture to enable flexible federation. So it's completely okay to have multiple transparency services. You don't have to agree on a single transparency service for it to have some use. And one important mechanism that has been Antoine skipped is this use of policies, so that you can actually state in your policies which transparency services are good enough from your viewpoint as a consumer of a claim to know that it's auditable. Another very important point is that as was said earlier, once a claim is issued, there may be some access control and its dissemination, but essentially it's out there, and it's perfectly acceptable for the same claim to be registered in intermediate transparency service to make sure that it remains available. So on the slide, for example, if OS vendor doesn't know or doesn't trust transparency service 1, it would typically re-register the first claim onto its own transparency service, or possibly on transparency service 3 to make sure that it passes the relying parties policies. And we are building a lot of flexibility there. Now you can have a policy that is super demanding, but that's really not mandated by the architecture.
I guess I'm next. Dan Rutze, AT&T again. I like the way it is depicted. I'm just concerned about how a cloud, how do we address this in a SaaS or infrastructure as a service model, in which you're basically running some applications or some workloads on a cloud provider? How do you trace the dependencies? And that's one use case that I think it's missing in our work, because it is a very complex dependency, because you don't know exactly what you're running on top as a customer, unless you have some very well packaged claims that say, well, these were given to you. But maybe that is the solution. I just don't know. I think it will be worth taking into account that, especially since you brought up because in the end, I represent an operator, and for us, risk management is the most important thing. And what we want to know is if there's an incident, how do I make sure that I assess my risk? I shut down some applications, I turn off some devices, whatever, right? So I want to be able to use that use case rather than going from the issuer to the verifier. I want to do it the other way around.
Yeah. So
selfishly, but that's the way it is.
Yeah. So it's a great point. Like, we're telling a story kind of in the line of the original definition of the supply chain from the first slide, starting with the raw materials producer. There's another way to tell that story, starting with the end consumer sort of experience of using an artifact. We tried to tell the story in the software use case. The final artifact is having some challenges, and how do I trace backwards from that final artifact? And every step of the way that components of that artifact were integrated and passed along, there was a risk assessment, maybe not a good one, but there could have been, and we can improve the quality of the risk assessment at that time that the evaluation is made by making it easier to identify the information that's relevant to the risk assessment. And that's the sort of one of the higher level objectives.
And to be clear, the risk management on software, supply chain is only one piece of the big puzzle. You got processes, you got, actual physical supply chains and other things. But I just want to emphasize the fact that we should look from a customer perspective, from the user's perspective, from an operator perspective. Well, why do you need this in the first place? Well, the reason is because we want to be able to know what's affected, how can we remediate, and how to address the issue. Thank you.
Hey, Ori.
Hey.
I love the architecture. I'm seeing it makes a lot of sense. One of the questions I had, and it refers to someone when we were looking at the receipt structure, the receipt, basically, the statement was made, the receipt claimed, or the receipt provides verification that all the steps above have proceeded, like kind of the thing has been registered, it was signed, it was accepted, the notary executed its policy. How do you deal with policy changes over time? Because there are certain inferences I want to make from the fact that I have receipt from this instance of this SCITT, knowing what I know about its policy. But if that policy changes, that's going to change the inferences I can make given the receipt.
So one of the things we've already looked at, and there's been some prototyping of evaluating this, is embedding parts of the policy in the registries themselves as claims. So you can imagine a bootstrapping scenario for a transparency service that maybe the first couple claims are all the current state of the art for the policies that will be used to evaluate subsequent claims that might be included. Then over time, when one of those changes, you can actually provide a receipt that the policy changed. And then when there's an attempt to register something that violates the latest policy but would have previously been accepted, you have some ability to even explain exactly what's going on as part of that.
That makes a lot of sense. And that's when I was thinking through this problem, that's kind of where my mind went to the first. But you then have trust in the operator of the notary in a way that you didn't before, right? And that you're then trusting them to keep their policy up to date, to keep registering and keep me apprised of the latest. Whereas a malicious transparency service will change its policy over time and prevent, or rather present different types of split views. Yes. This receipt over here met this policy, this receipt over here didn't, and I wouldn't necessarily know about it.
Yeah, so that's an important part. And I think we skipped over the freshness component in your slides, Antoine, but there is a freshness component that answers part of that question. So if I wanted to prove that a given policy that was evaluated as part of a registration was the latest, there is a mechanism to do that, and there's tree structures underneath there's a tree structure that supports the inclusion of the claims. There's many different terms for this, but one term I think of it as the right tree. And then there's a tree structure that can help support the freshness of the receipts. I think of that as a read tree sometimes. Combining these two allows you to answer these kinds of questions you're asking. However, you are trusting that transparency service operator to manage these trees consistently. So if you don't trust a single entity to do that fairly, then you might even want a multi-service system that was mentioned, by Karsten and Cedric as well.
That makes sense. So I think, I would say in terms of feedback, like making that point explicit about what things you are and aren't trusting in this architecture, because I think that there is this assumption that you don't need to trust the transparency service.
Yeah.
Actually, you look at it and maybe you do. The other quick comment I had was earlier there was a comment about timestamps. When you have multiple instances, does SCITT have things to say about how we keep those timestamps, have timestamp integrity and things like rough time and so on?
Hank, go.
He's on the queue anyway.
Okay.
Yeah. I'll step down. Thank you.
Hi, Ori. Chris Donacio, CMU. So I just, maybe it's more to you, Antoine. So if you don't, somebody mentioned the comment and there was an answer about if you don't trust Transparency Service 1, then maybe you have the, does that, you don't trust Transparency Service 1 and so then you re-sign it? So like, help me understand because time matters a lot here. So if you don't trust a service that a provider is using, then realistically you have to ask whatever provider to provide to at date of issuance go to multiple transparency services, right?
I'll try. Antoine gave the answer before. I'll try it again. In the case of receipt 1, the timestamp for that is related to claim 1 in that transparency service. In the case of if I want to anchor claim 1 again to transparency service 2, I'm going to get a different time for that anchoring. And so that's totally okay. And there's a lot of reasons why you might want to do that. And I think Antoine or Cedric mentioned some
okay,
of
so
them.
maybe I misheard it for the explanation. So I'm good. I just was looking for the clarification.
So hi, this is Hank. So I had heard SaaS before, and exactly. So we have a megaton of things here in the IETF that are dealing with trustworthiness proofs and RATs and such. One idea, of course, that we initially already highlighted in the first BOF is that every node, that a transparency service is not a monolithic service, it can be a set of replicant nodes. All of these must have the independent integrity proof based on RATs technology, remote attestation, be it TCG, global platform, IETF, or all of them at the same time. There's a lot of, if Dave said us here, there's a lot of CCC output that is going to classify the qualities of the nodes you're running on, the confidentiality, for example, in this case. And there's a corresponding ID called attestation results for secure interaction in RATs that can basically be incorporated in a receipt to understand what are the qualities I'm trusting in here right now. So these are trustworthiness qualities that you trust, not only just assertions. Then we were talking about freshness and time. Also a very strong RAT topic. So inside a node of redundant consensus protocol working nodes of a transparency service, you can have a distribution of a new epoch of freshness with epoch markers using, for example, signed CBOR time tags or traditional TSA, TS timestamp token info things. So timing is of course very important to us, but this is complexity that we didn't want to bring up in the first session. But yes, we're thinking about that, of course. Thank you.
Yes, Antoine again. So I just want to say a few words on these questions about policy and policy updates, because we didn't really cover that in the architecture. So, so I think this is quite important, right? That for the verifier, you want, in some cases, to have some ideas of what policy were applied. And we are discussing, as part of the architecture, some mechanism to actually have ways to indicate in the claim itself what policies are meant to be applied. So I think one of the very important kind of claim that we have is sequential claims. So a claim that updates another one. And in that case, even if internally the notary knows that a claim is more recent than another one, it's not necessarily obvious to the verifier without having to look at the payload, right? So this is why there is kind of this topic of being able to have a declaration of registration policy that can actually be interpreted by verifiers. And so that's kind of one way to better understand the guarantees that you get at the verifier from checking the receipt. And there is also this aspect of freshness, which is very important, right? So if you are using a piece of code, you want to know that you have the latest version. That's a very, very common use case. And I think for that, as Ori said, we can actually specialize the receipts. So we can have form of receipts to prove OCSP style that you have checked your receipt is relatively fresh for a given window. And you can do that without having to do any online check, just as we have with stapled OCSP, right? So this is a kind of mechanism that can be used to address this policy and between different transparency services.
Yeah, just one point on the registration piece. In this visual you have here, you have claim 1, claim 2, and claim 3, and they're coming into 3 individual transparency services. That means they're each being evaluated against the registration policy for that service. There's a minimum set of evaluation, which was mentioned previously, and you can imagine actually all 3 of these sharing additional policies layering. So that they're all going to implement the minimum in their own way, but they might be able to share actually major chunks of policies amongst each other for specific to certain content types, for example. You can imagine a lot of use cases where they've all agreed to handle, you know, SPDX, SBOM in a very specific way, and they can all share the policy for evaluating those forms of claims.
Yes, and to the last question, which was, how do you actually trust that that policy that was meant to be applied at TS1 was actually applied, right? And this is where using things like remote attestations or attestation to actually prove that that transparency server applies the policy as it claims. Of course, you always have the auditability aspects, but that gives you only a posteriori guarantee. If you want a guarantee at registration time, then you need something stronger.
Thank you. I wanted to highlight the point which Dan mentioned here. Is a great point that these slides start from the device manufacturer, but thinking from a cloud service provider, I think what I want to touch base on what exactly Henk I wanted to highlight or elaborate more, that in confidential computing, we do talk about workload measurements and workload attestation. So that precisely address the concerns the cloud service providers or the users of the cloud may have about the security guarantees provided by the applications that run in that kind of an environment. So though we have not explicitly put a slide which goes the other direction, but that doesn't mean that we have ignored that kind of an aspect into the system. And second thing I wanted to highlight is these transparency services, as Anton mentioned, has a very well connectivity to the RATS architecture, where these transparency services, when running in a particular security boundaries, can very well attested to enhance the trustworthiness of these services. Okay, thank you.
Okay. Thanks, Ori. So we've consumed our AOP and wrap-up time. But it was a good discussion, so we didn't want to stop it. But if there's anything someone has would like to bring up, Dan?
Thank you. One last comment. I like this work, and I think it will benefit tremendously companies like mine. One thing that concerns me the most that I didn't hear a word about SBOMs in this discussion, and it may be implied, but there are these standards that already trace dependencies. So if I have actually an SBOM that is truly built from ground up, with all the dependencies and the digital signatures and the the traceability, at that point it is a combined artifact, and it is probably what many people assume. But I'd like to make sure that in the process we acknowledge the fact that there are already standards, and we may have hybrid modes of addressing this. And I want to make sure that that's actually captured, because it may come out as basically we're creating another, we're decomposing the SBOM into some atomic artifacts that then can be traced. Thank you.
Sorry, I know why I asked Hannes, because we are running out of time, so I'm not sure whether I should be speaking here. But Dan, great point. I think in my slide I mentioned explicitly about SBOM. So on my slide, software use cases, one slide does mention about SBOM. Yes, we greatly acknowledge the great work they have done. And that is a first step of standardization, where you standardize the software dependencies or the components, various components using SBOMs, be it SPDX or CycloneDS. What we are building is on top of SBOM, where we add the transparency to the SBOM delivery mechanism and SBOM verifiability mechanism. So it's step ahead in the right direction. Thank you.
Yeah, we unfortunately ran out of time.
Maybe allow me for a quick comment. Yeah, this is just come up to my mind, and the examples here shows that claims are some specific content. But what if the claim says that please refer to some URL link to see the details and yeah. Okay, very good. Thank you.
Yeah, thank you all, and thank you specifically, Kay, for taking notes. There was obviously a lot of discussion.